The second half of Chapter 5 talks about data resource management. There are various types of databases, not just types of database structures, and how they're used in business today. So we need to discuss those and provide you examples of how each one of those operate. Data is an organizational resource that just like other resources within a business, data are an organizational resource that must be managed just like any other, just like buildings and just like human resources. In this diagram, we identified that there are various different types of databases in use. One is a distributed database or intranets with other networks. Another type of database is an end-user database. Then there's a data warehouse, which also contains multiple data marts. Then there's operational databases, and then there's external databases on the internet and online services. All of these databases contain information and data that is critical to the business and how the business functions. Operational databases are data that's stored locally to support business processes and operations. Normally, that type of data must be contained locally so it can be accessed quickly. Transactional databases also fall in the line of operational databases. Then there's distributed databases. Many organizations that are regional, national, or global rely on these distributed databases over multiple locations. They keep the data in sync by using one of two methods. One method is called replication, and the other is called duplication. Replication can be much faster as it only updates specific fields of the database that have changed. Duplication is like copying the entire database. It's slower and much more inefficient, but sometimes you need that slowness and inefficiency to be absolutely 100% correct. There's a lot of databases that are outside the firm that are free or fee-based. Here at APU, an example of those databases is our library resources, where we have access to a multitude of different databases that contain information on periodicals, articles, and books. Those external databases are sometimes available for free, or sometimes we pay a subscription fee on an annual basis to gain access to them. Another type of database is in hypermedia databases. Normally, these hypermedia databases have multimedia content, sound and video files in them that help us display that information to the internet much faster. A data warehouse is comprised of data that is extracted from other databases and stored in the data warehouse so the associations and the relationships between the data can be taken advantage of. Normally within the data warehouse, there are multiple data marts, which is a subset of the data so that it can be encapsulated or organized in a specific manner based upon a type of topic. For example, a data mart may be customers, a data mart might be products, a data mart may be sales. To extract data out of the data warehouse and the data marts, we use techniques called data mining. This allows us to reveal hidden patterns and trends that is not otherwise obvious. This diagram shows the components of a data warehouse system. On the left-hand side, we have the operational or external databases that are feeding information in through data acquisition to capture, clean, transform, transport, load, and apply data into the data management system on the top of the middle bar. That data management system then has an analytical data store, an enterprise data warehouse, and then the data marts, which then goes over to the data analysis, which is identified by the client computer, where work is actually performed and the data mining occurs, which then leads down into the meta directory and meta repository, which is part of the meta management. which is part of the warehouse design. If you see the flow there, you can follow and trace the components of the data warehouse system. This is a diagram that shows the applications on the left-hand side, the data warehouse in the middle, and the different data marts on the right-hand side. This allows us to organize the data in a much more logical fashion. So at the top of the application stack, you see the ERP, which is also called the Enterprise Resource Planning System. Then below that we have the Inventory Control System, the Logistics, then Shipping, Purchasing, and at the bottom is CRM, or Customer Relationship Management. All of the data from those different application databases go into the data warehouse. Then the data marts on the right-hand side of finance, marketing, sales, accounting, and management reporting systems extract the data from that data warehouse so that they can perform the analytics and decision making for the business. Data mining extracts business knowledge from data warehouses in a very specific and very sophisticated and complex execution. So on the left-hand side we have the databases. We have a selection process to get the target data through data transformation into our data warehouses. Then we use data mining techniques to extract the data and develop patterns and trends that we then interpret to evaluate, and then that is called business knowledge. Remember we had talked about knowledge management systems? Occasionally, that interpretation and evaluation process itself is documented and held in the knowledge management systems. In the traditional file processing system that we used to have, data was stored in independent files without regard to other needs for that data. In other words, we would store the accounting system data in an accounting system so that we could provide the general ledger reports, the balance sheet, and the profit loss statements. But we never really used that information outside of that system. Not so today. Some of the problems with processing like that is data redundancy. The same data is kept in more than one location, and databases seek to control, not reduce, redundancy. This led to data inconsistency. For example, if you had salary data in your accounts payable system that you were paying out to your employees, and you needed to identify where sales were in terms of how much money were you paying to salesmen, you would have that information duplicated in your accounting system and potentially over in your sales system. Wherever you have data redundancy in multiple locations, you run the risk of having data inconsistency and data inaccuracy, and that is what kills businesses. Other problems that we had with the traditional filing processing was a lack of integration. Data could not be easily associated and related for different ad hoc requests. Ad hoc means unplanned and kind of on the fly requests. Also, we lacked data dependence, or we had data dependence. Data and programs were tightly coupled, which meant that we couldn't interchange that data or those programs with other business processes. And then it lacked data integrity and standardization. Data was defined differently for different programs, different databases, and different end users. The same piece of data. Let me give you an example. What is an address? Well, an address sounds pretty commonplace. Everybody understands what an address is. But how many addresses do you have? Do you have an emergency contact address? That might be your parents or a guardian or a friend. You have your current address, where you currently live. You might have a home address where you actually reside, maybe with your parents or others. So you can have multiple addresses, so you have to be very specific about that information, and there has to be standards about that information. For example, does an addressing scheme that we use here in the United States applicable to outside the United States? No, in fact it's not. In fact, it doesn't even work in Canada. Canada addressing is different than street addressing here in the United States, which is different than other places in the world. Hence, standardization is required for business processes and for databases to have data integrity. The current database management approach, which is our current way of doing things, allows us to consolidate data from different locations and allows it accessible to multiple applications at the same time. For example, APU utilizes PeopleSoft. PeopleSoft is comprised of over 1,500 different files within the database system. That allows multiple applications to access the same data from different applications, so we don't have data duplication. The database management system that we utilize at APU is called Oracle. And so Oracle contains a collection of programs written in PeopleSoft that allow us to create, maintain, and use data within the databases. Oracle has its own set of maintenance tools and utilities that help us organize the data and keep it updated on a continual basis. The application development tool that we use to help facilitate the data manipulation language, or DML, provided by the database management system is called PeopleTools. So PeopleTools is the actual application development system that we use at APU. In many functional areas within organizations, they understand the database and the data residing in the database to such an intimate level that many functional people outside of the information technology department learn a language called SQL. This is a query language that allows users to perform ad hoc requests of the database. Again, ad hoc means not predefined, not pre-programmed, but you can just stand down on the keyboard and create a query that will extract the data from the database. That's called structured query language. Structured query language is pretty much the de facto standard for all relational database management systems that we use today. Oracle being the one that we use here at APU, and it uses SQL. One of the hallmarks of SQL is it uses what's called Boolean logic, which has three logical operators, and, or, and not. These are very powerful logical operators that allow us to extract the correct data. Many of the structured query language utilities have a graphical and natural query language that makes it easier and sometimes converts those queries into SQL statements for us to make it much easier to extract data.